Hello, everyone, and welcome to the Switch Statement Podcast. It's a podcast for investigations into miscellaneous tech topics.
This is episode 5 in our series on The Design of Everyday Things by Don Norman.
Howdy, John. How's
Hey,
your
Matt.
life?
Life is grand. How's yours?
My life is okay. I just recently got a Google Glass. It's the next
Dude.
wave in computing technology, and it was the wave 10 years ago or so.
I know, I was going to say next wave.
But it's once in future wave of technology, I would say.
I agree. I am very bullish on AR, VR, things like Google Glass. I think they're going to...
Apple's coming out with something, so I think
Yep.
time is ripe. But as
Totally.
discussed last time, I am planning on using my Google Glass to extend my ability as a human to
Tool user.
amplify. What's that?
You're tool
I'm a
using.
tool user. I'm almost becoming a tool.
No
Because
way.
of Google Glass.
Okay, so I should tell the audience that I already knew you had a Google Glass
Whoa.
because we meet all the time and talk about this stuff.
Pulling the curtain back.
But I have been wanting to get a Google Glass
No.
because of your recent experiences with it. Like, it actually, it just seems like it offers certain features that are really hard to get otherwise.
We could be at the cutting edge of. I want to publish Glass primitives for Flutter because I think Flutter is actually the perfect technology to use for Google Glass because
Yes.
you have to develop it on this very old version of Android. So it's like, Flutter can develop apps back to API level 16 as long as you don't.
Wait,
so-
does Glass doesn't support like the newest versions of Android?
No, it's Android 8.
Oh,
So,
what the?
so I'm guessing that if you wanted to do Android development, it would be kind of old Android development. Like you might not be able to use all. And I don't know how it works in terms of like targeting older devices. It's probably similar, but where you can use some sort of compat thing and you can compile for an older target, but and still use all your new niceness. But anyway, so that is. I don't know. I think that could be a big thing. I think Flutter's a good way to develop it. So.
Agree. Yeah. No, you could seed the ecosystem. And I don't know, that sounds like a super valuable thing that you could do for the world.
Indeed. But today is our kind of grab bag second part to Knowledge in the Head and in the World.
Right.
Chapter of Design of Everyday Things by Don Norman.
So we're talking about things like mental models, mappings, probably talk a little bit about memory, even though that was the topic of the last episode, but they're just so interrelated, it's hard to avoid that.
Yeah. Yeah, and that's all right.
One thing I thought was cool about this chapter that he kind of touched on, but it's a topic that I'm very, very interested in, is kind of operating at different levels of abstraction. Mm-hmm. And one of the examples he uses is how imprecision is often very okay.
Yes.
Like if you have some model that allows you to convert from Celsius to Fahrenheit very quickly, it's okay if it's not exactly correct every single time. Or if you have some ability to estimate the values of multiplying large numbers, it's usually okay if you're estimating. And I just wanted to take this idea a bit further because I've seen this a lot in my profession where, and I'll use a concrete example, like I'll be at a design review and there's maybe like a very senior engineer, or, usually it's a senior engineer who offers what I perceive as just like a very insightful comment about like a design. And I'm like, oh my God, how is this person that tuned in, to where they sort of understand the whole system and understand this new design in such a way that they can offer this great comment. And I've come to realize that I think it's partially that they're just very good at like ratcheting into the right level of abstraction to think about the design and think about the problem. And, the example that I was thinking about was, maybe you're dealing with a problem that's where like Einsteinian, like relativistic physics, which actually should be called relative physics now that I think about it. But yeah, relativistic physics is what you should be using to solve the problem. But you're sitting around trying to solve that problem with like a Schrodinger's equation. I'm assuming it would make it harder on yourself, because you're just kind of operating at this abstraction that's not really necessary. And yeah, I've witnessed that in my career, and it's something, that I think I've slowly gotten better at, but, also want to continue to improve. It's just like figuring out that right level, what should I be thinking about? And sort of what level should I try to keep my thinking at in order to be as helpful as possible?
Yes. I think it's a really hard problem because I think as an engineer, you very quickly drill down into like coding is this very fine-grained level.
Yes. Yeah.
And so I think it takes a real practice to code at a higher level of abstraction. Code the way he was calculating those numbers. You know what I mean? Because it's like, I think coding can be actually done at a lot of different layers, just like you could do math at a bunch of different layers of abstraction or precision.
Yeah.
And I think when you're learning engineering, I think a new engineer will be like, all right, I got to solve this to the finest degree that I know how to every single time.
Right.
And that's not necessarily always the right way to approach it. And actually, in general, I think it's not the right way to do it.
No, yeah, exactly. Like engineers just have this innate usually learned ability to like jump into code and, try to figure something out almost like algorithmically, when a lot of time it just makes so much more sense to think about kind of modules communicating with one another, or what's the network topology of this system, or just something at a much higher level. And I think if you can, people that I've seen who are really good and kind of have a lot of expertise, they're sort of able to like shift between those levels just effortlessly.
Right. So I had a question for you. He talks about natural mappings in this chapter, which I think kind of relates to what you're talking about, where you have however you're interacting with something and then mapping onto what effect is taking place. So he talks a lot about burners on a stove where he has the arrangement of you have the arrangement of the knobs, which controls the burners, and then you have the arrangement of the burners themselves. Mm-hmm. And you have a mapping here between the knob and the burner it controls. And if you do it wrong, it can be very confusing about like which knob is controlling which burner. And I was curious. I was just interested in thinking about mappings in UI design. Is there a... Because I think it's very easy to think about how mapping works in the context of a physical object. You've got physical object 1 and physical object 2, and physical object 1 controls physical object 2.
Right. I mean, he gave the example. I don't know if this fits with what you're thinking about, but he gave the example of like scrolling on a web page.
Yes.
Which I did find interesting because I don't want to assume anything, but I think he's a Mac user.
Yes.
And he seems
a fan of Apple generally.
Yeah, he seems very, pro Apple, which is great. I don't have any problems with that. But he describes yeah, I guess I should give some background here. He describes how, scrolling on a website has generally worked where when you move your scroll wheel on your mouse, you're moving the scroll bar on the website. So if you scroll down, the scroll bar goes down, the content of the website actually goes up.
Right.
Because you're kind of, you can almost think of it as like a camera that's looking at the website that you're like pulling down.
You're moving the window on the content, essentially,
Exactly.
The window is moving down.
Yes. And he contrasts that with like a handheld touch screen device where as a human, what you expect is that when you touch and drag the content, that the content goes in the direction that you're dragging. So what that means is if you, touch and move up, the content moves up. So it's kind of the complete opposite end result, from a mouse and keyboard thing versus like a touchscreen thing. And he sort of describes that as though it's a problem or as though it's like a mistake in design, which I just found myself not agreeing with. And I wonder if it's because I have the Stockholm Syndrome, like I've just used PCs for so long that it feels natural to me. But I also do see it as like two different metaphors, which I thought was interesting.
It's interesting because one thing that stuck out to me about that is he said, "Oh, no other company followed Apple's lead," and it's like they can't be leading if anyone. It's more like made the same kind of change. It's not a lead if no one else did it.
If no one else does it, yes.
The
industry generally does not do it, yeah.
But I would say I could see a world where I get used to the mental model of when I'm scrolling down, I'm actually like pulling the content down. Like let's say I'm on a laptop. Yeah. I could see I'm pulling the content down, or I'm two finger scrolling on the trackpad that pulls the content down. Maybe, because that's the way that it works on, on like Apple computers today. Sorry, this is like right. So. What I cannot get behind is that the scroll wheel. Like what they did was they made the scroll wheel and the touchpad the same, which the scroll is a completely different metaphor. Like, the interaction is completely different. So it feels like they should be independently controllable, frankly.
Yeah. No, agree. It's, I don't know. I just thought it was yet another interesting example of the author. He has his own life experience and opinions.
Yeah.
And that's fine. But I found myself sort of disagreeing with the premise.
Yeah. But that is a good point. It's interesting because it goes back to the interaction with the physical. Where, and so I guess maybe this would come in with like something like drag and drop. Where like there's expectations about how what you're doing maps onto what actually winds up happening, but yes. I don't know. Yeah. I think it's hard. I think it is different than, like it's not as salient. It's not as something that comes to mind as much when you're designing a user interface versus a physical product.
Right. Yeah, it is interesting. I'm struggling to come up with other examples where, you have some mapping between, like the stove example, where you have some mapping between some objects, maybe on your screen and something taking place. Maybe in like video games that happens. But the only examples I can think of are like, basically video games where they are modeling like a real world situation where there's like a mapping, which I don't think really counts. So Yeah. Another thing we could chat about, and this sort of goes back into the memory thing, but he talked about an interesting memory example with pilots and air traffic controllers, and how air traffic controllers basically are constantly giving pilots this like fire hose of information, like, which is all incredibly, incredibly important, because obviously they could crash into other planes, or they could, miss the runway or whatever. I mean, any number of horrible things could happen. And how pilots are able to like intake all of that information using a combination of like in real time inputting the information into their tools, writing stuff down, and also just having like a strong sort of working knowledge of of this world and how all this stuff works. And I thought this was an interesting example because you see a lot of situations where people are having to take in this tremendous amount of information and process it very quickly. And you always ask yourself, like, how are they doing that? But then when you really break it down, they're humans. They're not like, some kind of godlike creature, but they're using all of these different techniques all at the same time to kind of perform this extremely, difficult task. And I thought that was pretty cool. It also reminded me, have you ever seen the movie United 93?
I don't think I have, no.
Awesome movie, by the way, but it's a sad movie. It's about the fourth plane that was involved in the 9/11 hijacking that I think it like ended up crashing in a farm somewhere in like Pennsylvania or something. But anyway, the reason I bring that up is because a lot of the film is air traffic controllers, like talking to pilots and just that interaction. And I think the film actually did a really good job of like sort of showing the hectic nature of like what an air traffic control room looks like, and how pilots are just receiving this insane fire hose of info. So it really made me think of that.
Yeah, one of the cool things he talked about there was pilots, they hear something and then they very quickly do something and they put that information back into the world, which I thought was a very interesting idea that I've never really thought about before. How it's like the world can actually be a store of information too, like that a user can actually put things into. It's not only just this static interface that provides information.
Yeah. It's also just a testament to like, if you are able to, process and react to information quickly enough, you can sort of have this real-time, thing where, because, doing something in real time and then dropping into that like non-real time mode where you're processing and you're thinking about stuff, it's so vastly different. And the real-time mode is so much more efficient. So, like just my job, for example, I get tons of pings all the time, and I'm to all these distractions, like review this doc, write this code, talk to this person. And I have found that if I can kind of process it all in real time and respond to it immediately, it's less stressful, even though I'm still receiving the same amount of input and giving, hopefully the same amount of output. It's just less stressful because it's like I think I'm not taxing myself as much. And yeah, it's an interesting way of viewing like those complicated professions.
Yeah, it's hard. I don't know that I have a perfect answer for that like real time disruption thing, but all right. Well, I think that was all that I had for this part.
That's all I got.
All right. So, well, we'll see. Let's just see really quick. Let's see what the next chapter is. So the next chapter is called Knowing What to Do, Constraints, Discoverability, and Feedback.
Oh, okay. That sounds fun. Stuff that I know about.
Interesting.
Yeah.
All right. Well, I'll see you there, John.
All right. See you there. Have a good one.
All right. Bye.
Bye.